Hello everyone, I'm RoboTou. RoboTou Stacker is a software specifically designed for time-lapse stacking. For starry sky time-lapses, it aligns star points before performing stacking. Next is the tutorial on how to use RoboTou Stacker. First, when we open the software, we'll see that it has modules including starry sky time-lapse stacking, starry sky fisheye time-lapse stacking, starry sky reflection time-lapse stacking, starry sky direct recording video stacking, reduce star, landscape time-lapse stacking, and decode raw, with a task queue at the end. This software is intended for fixed camera positions, meaning the camera should be mounted on a tripod and kept stationary throughout the shooting. If the camera moves or shakes during shooting, this software isn't suitable. The software supports 3 image formats: TIFF, JPG, and RAW. Let's start with the typical application scenario of starry sky time-lapse stacking. This is a typical file structure for starry sky time-lapse stacking, consisting of an input folder, an output folder, and a mask image. We have a separate tutorial on how to create the mask image. Simply drag the input folder, output folder, and mask image onto their respective buttons to complete the input and output settings. Here, there's an autofill mask holes option. This is useful for starry sky time-lapse scenes where there are foreground elements like tree branches and leaves, with visible sky through the gaps. Checking this option helps prevent interference with star alignment and effectively mitigates such issues. Then there's the auto-skip unaligned frames option. For day-to-night or night-to-day time-lapses, when alignment fails due to the absence of stars during the day or excessive cloud cover blocking stars at night, checking this option will skip these unalignable frames and continue aligning and stacking subsequent sequences. There are 4 stack types: mean, median, max, and minute. Mean offers the best noise reduction and is faster than median but isn't as effective at flicker removal. Median provides slightly less noise reduction than mean but excels at flicker removal. You can choose the appropriate stacking type based on your needs. The default is median. There's also a stack size setting, which refers to how many input images are used to generate each stacked result. Once all settings are configured, you can click Start to run the process immediately or right-click to add it to the task queue for processing in the queue. When we start the process, it will display the number of stars currently aligned and the minimum number of stars aligned in the entire sequence. Below that, there's a progress bar and status bar showing the total number of images and which one is currently being processed. I want to emphasize that the number of output images equals the number of input images minus the stacking count plus 1. That's the calculation formula. Let's wait for it to finish processing. While it's running, let's check what's in the output folder. We'll find files prefixed with Stacker, and the file names after Stacker correspond one-to-one with the input image file names. They represent the same frame but processed through stacking to produce a noise-reduced and flicker-free output image. We can compare A7R00005.tiff from the input folder with Stacker_A7R00005.tiff from the output folder. Opening them in Photoshop, we can see that the stacked image is much cleaner with significantly reduced noise compared to the original. Okay, it's finished processing. Let's look at the final video. This is the starry sky time-lapse sequence processed through LR time-lapse, showing noticeable noise, flicker, and even a person appearing in the frame. Now let's look at the stacked video. The frame is extremely clean, the person has been removed through stacking, there's no flicker at all, and the motion is very smooth. After some minor color grading on the stacked video, we get the final footage, which is smooth and clean as you can see. Okay, that covers the starry time-lapse stacking. There's also the starry fisheye time-lapse stacking, which is suitable for starry sky time-lapses shot with a fisheye lens. It functions similarly to the regular starry sky time-lapse stacking, but due to the significant distortion of fisheye lenses that can prevent proper alignment of stars at the edges, it splits the sky into two parts. Each part is aligned and stacked separately before being stitched together. The starry reflection time-lapse stacking is designed for scenes with water surfaces reflecting the starry sky. Unlike the regular starry sky stacking, it requires two masks, one for sky and ground, with the sky in white and everything else in black, and another for reflections, with the reflection area in white and everything else in black. The starry recording video stacking is suitable for starry sky videos directly recorded with cameras with good high-sensitivity performance. The difference here is that it takes a video file as input and features a Preserve Meteors option. When checked, it will try to preserve meteors while stacking. The Reduce Star module currently has some issues and isn't recommended for use, but it will be improved in the future. If needed, you can batch reduce stars by recording actions in Photoshop. The landscape time-lapse stacking is suitable for shooting time-lapses of sunrises, sunsets, clouds, waterfalls, and other landscapes. Stacking can create silky cloud effects and smooth water surfaces. Unlike starry sky stacking, it doesn't require a mask. In the toolbox, there's a raw decoding function. While the software can stack raw format images, since starry sky stacking requires mask creation and the resolution of raw files decoded by this software differs from that decoded by Photoshop, you'll need to first decode one raw file using this function and then use the result to create your mask for raw format stacking. There are two workflows for processing time-lapse sequences with this software. First, perform color grading and transitions in LR time-lapse. Then batch export TIFF files using Lightroom or Bridge, stack them, and finally render the video. Second, first stack the raw format files using this software, then convert the stacked TIFF files to DNG in Lightroom, perform color grading and transitions in LR time-lapse, and finally render the video. In fact, the first workflow yields the best results. In the bottom left corner of the software, there are settings for interface language and image resolution. Default is 4K. Selecting source will use the original image resolution. The software mode can be set to normal or expert. The difference is that expert mode allows for flat field and dark frame calibration, provided you have captured such frames. Any changes made in the settings require a software restart to take effect. At the bottom, there are also options for activation and help, which includes the user manual, video tutorials, and even my contact information. Feel free to reach out if you have any questions. There's also an About section. Okay, that concludes our video tutorial.